Hey guys, Mythidas here. Today is going to be the first video of my game engine series, and I'm just going to be covering the progress of my game engine, the Wyvern Engine. Now, I've been working on this engine for about 4 months, and I kind of want to go just over an overview of the design, what libraries I'm using for the engine, and show off what's currently available. So starting with the libraries, I do have async for 3D model loading and materials. I am Gizmo for manipulating entities in my scenes, FreeType for font loading, GLAD is used for my OpenGL code, GLFW is used for my window creation, GLM is the math library, IamGUI is all the GUI code, and IamGizmo actually integrates with that library, so they work well together. STB image just loads image files, and YAML CPP is what I've chosen as my file format and my library for saving to that file format for all the serialization. Unity also uses that for their scenes, so I thought it was a good pick. So the project's actually broken down into 3 sub-projects. I have the Wyvern Engine project, and this project down here is just used for all the engine code, physics, rendering, anything that's going to be boilerplate. You've got the Wyvern Editor project, that's where I put all the boilerplate for the editor, so it has all the code for creating new windows, adding inputs to windows, adding the editor views for the components when you select a component. So that's pretty much where you just use that library to create anything for the editor, kind of like in Unity where you would create an editor script to change the editor for a component. It kind of works similar in my editor as well, and all of that code actually gets cut out when you run the application in release versus debug. So if you run in release, all that code gets cut, saving performance. Now the builder is where you actually build the application. It allows you to load the application, add custom assets like sprites or anything, materials, and it lets you also add custom scripts because I do support native C++ scripting. An example of a script over here is the scorekeeper. Now, when you create a new component or script, you want to inherit from this native script component, and what that will allow you to do is get the onAttach, onDestroy, onUpdate, onFixedUpdate, virtual overrides, and then you also get access to collision data whenever the entity you're attached to gets collided with by another rigid body or collider. So if you want just a trigger, you don't need to put a rigid body on it, and it could just be a trigger. Now you could also implement from component, and the only difference is that you just don't get access to the virtual voids. So a lot of the internal components only inherit from the component structure because they don't need those virtual voids. So it's a bit more flexible than mono behavior like Unity. You can kind of decide how much overhead you want to add to an entity component by inheriting from either one. Now within the component, you can see right here at this bottom I have this ugly code for serialization. This does 2 things. First, it will save the score variables that we put in here into the file to be loaded up when you use them, when you load the scene next time, or if you save and then exit and then re-enter the editor, it'll load that file keeping that information. But it also, up here on serialized component, this is what's used to put the component into the database to be used as a component. So it'll be visible in the component dropdown and selectable to add to an entity. Because C++ doesn't support reflection, I have to do it this way so that the compiler knows about the component, because there is no reflection at runtime, so you can't see what components inherit from a certain type magically like you can in C#. So this is the method that I use. Now I actually have a different implementation of serialization in my current branch because I didn't like this version, and it also, this version didn't support recursive serialization, so I couldn't just plop in another serializable object and have it automatically serialize. So I've actually implemented a new version of this in my current branch, and this is actually an example of something that I'd like to do a deeper dive on. So within this series, I do want to go over my engine, but I want to have you guys be able to leave a comment down below over a topic you want to see and cover it in a deeper fashion in more of a instructional video of how to implement it into any project instead of just what's in my project. Because serialization is one that I couldn't find anything on, so I realized that some people may benefit from seeing an implementation of that. So if you guys see anything that you want me to go over that I have in here, please just leave a comment down below and I will make sure to make a video on it. I want to make a video over a lot of things that I put in here that I just couldn't find any resources on the internet. Like 2D rendering, there's a lot of resources on that, but serialization, I could barely find anything. other than people just telling me to use boost, which I don't like using that library. Personal preference. So now that we've gone over the kind of structure of the project and kind of how to create a component, because that's pretty much all a game requires, is you to use the application and create components. Components pretty much drive everything. You don't have to worry about any of the other boilerplate code. It just kind of works in tandem with your components, and your application should work. So right now I pulled up the editor so we can kind of take a look at what the tools are currently available to use in the application to build a game. It does support entities, and it does support up to 32 components, and that's just a global variable that can be raised or lowered to support a maximum of whatever is desired. Now, a component is simply added by clicking the Add Component button, and anything that has that WV serialized shows up in this list as a component available to use. And all you got to do is click on it, and it will just add that component in. So if I add a camera component, it shows up here. If I delete the camera component, it disappears. Now, something cool about the components is that all these controls are from the editor application, and I do support drag and drop. So if you want to take like a texture and drag and drop onto the sprite box, it will actually change the sprite. And so you can kind of use the project dynamically, and whatever's in the project, you don't have to go into the code and change anything. A lot of the features I'm trying to add drag and drop support to. Now, of course, we do have the ability to come up here and play the scene, and it will run all the logic that is within the systems and within the components. Now, for systems, I have actually gone for a job-like system from Unity. It kind of just groups all of the components into one memory pool so they can be looped over at a time. So instead of looping over entities, you loop over a set of entities that have a similar signature of components. And so for the physics library, all it does is loop over any component that has a rigid body or a sphere collider, and it will do all the math accordingly based on those two components. And it won't worry about anything else on the entity, and it saves a lot of time and memory management by doing that. So because of this, I haven't added a way to add new systems to the list yet, but there will be a feature where you can create your own systems to loop over these entities instead of just using components and using the overrides on those, so that you can create new systems to be more efficient with the memory. But if you need to use the primitive type of virtual overrides for those, on attach, on destroy, on update, you have the ability to, so you can use either one you want to. So currently my physics engine is using the signature style job system, but everything else, like the scores on the right, are using the component style, like on collision system. So within the game, you can see that I do support inputs, so you can do any input from mouse to keyboard. It's all pulled from the glfw library, so all the inputs that are available within that library are available within my engine. And as you can see, the entity, whenever I hit a wall, gets destroyed on the right side, and once the entity actually destroys all of the scores on the right side, you'll see that the game pauses. Movement's no longer an option. The ball no longer moves because the engine is run on a time scale, and if you set the time scale to 0, it effectively pauses the game, but it only pauses physics assets. So if you want to use a button, so like in a main menu, you can set the time scale to 0 to pause, and then just set it back to 1 to continue the gameplay. Now, I do also support child entities, and those child entities do support being duplicated. So I do have a copy and paste feature in the game. There's currently no undo or redo system. That's going to take a bit of a rework, since it's kind of like a design philosophy and kind of like way of designing the project rather than just a feature you can implement. So duplication is kind of nice because you can create an asset and then just duplicate it. And as well, I don't have it in the engine in this build, but in a future build, it does support game objects just like Unity, because if you can duplicate it, you can write it to a file and save it there. So I will support game objects in the future, and so you can just save off game objects and save them for later, just like in Unity. So as of now, that is pretty much all the features that are supported within the game. Engine itself is just the editor and what I've kind of shown off, and everything in this demo right here is what's supported within the engine. There's nothing I've implemented that wasn't for this demo. I'm kind of building the engine as I build a game on the side. So like I said, in the future, I do hope to have some devlogs going over a game as well, but currently it's just the engine series. So if you guys see anything that you want more of an in-depth look at, or you want me to do a tutorial on, please leave that down in the comments. Most things in this are a custom imitation of my own. I like to follow some guides, but I like to do most of this on my own as an educational piece. And the 2D physics is actually not from Box 2D or anything. That's a custom implementation for physics that I've implemented. So if you want more information on how to set up a physics system, I can do a video on that too. But anything you guys see, please just leave a comment and just put it down below, and I will make sure to make a tutorial on it or show you guys how to implement it in your own projects. Now, if you guys enjoyed this video or you want to see more, please leave a like down below. If you guys want to see any of those tutorials, please like the video as well. I do look forward to making more videos, so I hope to see you guys in the next one. But until then, take care.